Hello, my name is Sung-Soo Hwang from Yeongnam University in Korea. So today we will talk about some of the key technologies of digital transformation, which are Internet of Things, Big Data and Analytics, Cloud and Edge Computing, Artificial Intelligence, and blockchains. So these technology trends are key elements of digital transformation. So basically, we have two objectives. First, understand what the key technologies are in this digital transformation. Second, we learn how to use these technologies for government decision makers. So we have four sections. First, quickly reviewing what the digital transformation is. And second part is most important, look at the new key technologies. And third, quickly overview the technology trends. And lastly, the most importantly, we're looking at the service model with the convergence of these key technologies. These key technologies all together. Fourth Industrial Revolution. Fourth Industrial Revolution is the first coined term to lead digital transformation. World Economic Forum, Klaus Schwab, initiated this term. Some like this term, some don't like this term, but wherever, some argue that the fourth industrial revolution is not too different third industrial revolution with the computing, internet revolution, but the two key things are new here. So first is hyperconnection. Second is hyperintelligence. So hyperconnection is a connection made by numerous sensors, which is we call it Internet of Things. So IoT contains lots of sensors and connected. So objects are connected with the objects, connected with the computer, and connected to people. So hyperintelligence, with the connected sensors, with the AI, artificial intelligence, makes some sort of automated decisions. For example, sensors detect the temperature of this room, temperature of my body, and controls the temperature and air conditioning and sorts of things like that. So those are two key things are a new concept. So that separates fourth industrial revolution. So Klaus Schwab, World Economic Forum, coined this term. Second, let's look at the key technologies. So recent study looked at all these IEE publications, found that these new keywords in this picture, cloud computing, system integration, autonomous vehicles are newly developed study subject, and this will change future jobs enormously. So same thing, fourth industrial revolutions are changing. So cyber changing the entire world, the company structures and driving digital transformations. Cybersecurity, artificial intelligence, Internet of Things, cloud computing. These are the key technologies that are happening in digital transformation paradigm. So let's look at what artificial intelligence is. So artificial intelligence is basically machine learning. So it is sort of derived from studying brain's neural network, looking at the synapses, outer layer, input layer, is input becomes output, output becomes another input, and center works as some sort of the CPU to handle the information. So it's called the deep learning. So if you look at the next slide, providing lots of billions of pictures to computers to study. So looking at the pictures of the cats, and then if you supply a picture of dog, then computer says it's not a picture of a cat. And then you supply lots of pictures of the dogs, and then computer tells it's a picture of cat or a picture of dog or none of these. So this is called the machine learning. There are three different kinds of artificial intelligence. We are now looking at the artificial narrow intelligence, which we just talked about. And artificial general intelligence is something like decision making of human. So general computers can make decisions same level as human. So super intelligence is computers can make decisions with computing power and human-like general decisions. So technological singularity will happen sometime in a next 100 years, so that computers can make pretty much the same decisions as humans. So that's the prediction of artificial intelligence study groups. And second, let's talk about big data and little data. So big data, the characteristics of big data, usually three key characteristics, and there is 5 today. Speed and velocity. Velocity is speed of data. So variety, different kinds of data. Volume, big volume, that's a big data. And also veracity is some sort of authenticity. The truth and accuracy is veracity, and value is it creating a new positive value. So that's 5. That's called the 5V of big data. So big data analytics analyzes and visualizes continuous stream of structured and unstructured data generated by digital communication. For example, sensors communicate with sensors and giving information to my smartphones. So what is little data? So little data is something like this. So big data is a data collected, all sorts of data collect this city. But little data is data collected in sensors attached to the street lights in front of my house. So specific location, specific customized data. So when something goes wrong in my area, it is detected rapidly and in real time that sends information to my household and through my household to the big data cloud. So it is targeted, customized, specialized data sets. So that's the little data. So big data and little data should be linked and streamlined to work well. Cloud computing. So cloud, figuratively speaking, is up in the sky. So through the LTE and 5G data travels from my smartphone, my computer, sensors in the street to the servers on the cloud. So cloud computing enables data processing and storage anytime, anywhere, from any device. So cloud computing is actually not new. It existed something called virtualization. So it worked as a virtual machine and servers, but now it evolved into cloud computing. So if you look at the first graph, before traditional infrastructures, the capacity and demand are fixed. So sometimes there is a shortage. Sometimes there's a lack of capacity. But cloud can actively adapt to the supply and demand curve. So next, Internet of Things. So Internet of the Things is essentially sensors. So in every object, they put sensors, and it communicates information through the internet to the servers and to people and computer. So it's connection. So it applies to smart city emergency responses, energy efficient smart homes, wearable health monitoring. So now we are seeing the commercials of Apple Watches and Google Watches so that it can monitor your health and your pulse and your overall health monitor. So this is the illustration of how all these Internet of Things and technology can work together. So bottom security is been usually enabled with the blockchain and other security measures. So devices are your smartphone, or watches, or wearable computings. Network is a 4G, 5Gs, also personal area network, usually sensors of the IoT and Bluetooth, Wi-Fi, all these networks. So platform, you develop hardware, software platforms, and with this kind of structure, you deploy services whether it is healthcare or smart grid of smart city or smart home. So blockchain in short explanation is there are many variations of blockchain technology for different domains, but for today, let me emphasize that this blockchain is used as a security measure. So for example, this blockchain technology in this server and this server communicates and double check this is authentic to each other, and they communicate and they authorize, they authenticate. So it is a kind of decentralized and distributed network because it doesn't have to go to the central hub all the time. This sensor and this sensor checks each other if they can communicate, and it's a distributed network. It's a decentralized trust system. So basically, the sensor in this monitor, sensor in this machine talks to each other. Without the blockchain, it cannot be trusted. This information comes directly from this sensor. But with the blockchain security measure, it confirms that this information comes from the specific location. So these slides explains that concept. The same thing. So let's look at the briefly Gartner's top 10 strategic technology trends for 2020. So it is people-centric, and it is smart space focused. Hyper-automation, empowered edge computing, distributed cloud networking, automation of IoT, AI and AI blockchain security. So we finally arrived at the conclusion of all these technologies to build service models. We named as cyber physical system. It's rough. It's not a catch name yet, but basically we have a system. It's like a digital twin. We have a system in cyberspace. We have a system in physical in reality. So we can communicate online and offline. We can streamline all these activities with these key technologies. So cloud and edge computing, big data, IoT, AI is enabling cyber physical system. So smart grid, let's look at the smart grid. In IoT, sends all the signals, and with edge computing and cloud computing, edge is this small area, contains small amount of sensors, and then compiling all these big amount of sensors, put in all this cloud computing. And big data and AI analyzes how this information flows, how these data indicate, and giving decisions and orders back to these physical sensors. And this is cyber physical system. So interactively communicating and anticipating changes and interventions and readily. So turning on switch here, turning off switch here, moving more resources, electricity, sending here from there. And these physical happenings are controlled in the cyberspace with the data in the cyberspace. So digital twin, this is an illustration of a smart factory. General Electronics is most famous for this. So let's say when something happens in a physical factory without an IoT, the old conveyor belt must stop. But if IoT is in place, in every small places, sensors and IoT are in place, and it sends real-time data 24 hours to the digital twin. Digital twin is a factory simulated in digital spaces. So if anomaly, if something out of order happens, the data is transmitted in real time. So digital twin sends a signal and alert in real time. It can proactively or it can real time goes to the very specific point to fix what's wrong within this certain sections of smart factory. So digital twin represent real-world objects. So in digital space, simulation of all these physical space operation, and physical space operation is simulated in digital space and applied to the physical space. So that's called digital twin. So a digital twin is a digital model of real-world entity or system. So Singapore is building this digital Singapore project. So they are building entire city's information in digital Singapore digital twin space. So whenever some traffic accident or some emergency happens in real world, simulation gives a very much automated and real-time remedies or actions or responses so that real-world problems are solved faster than it used to be. So the Korea's smart city projects are doing similar things in Busan and some other cities in Korea.